welcome to the Arm What Is Program series. In each episode, we explore a tech topic to give you insight and perspective into some of today's hottest design trends. I'm Brian Fuller, Editor-in-Chief at Arm, and today we're going to find out what is Arm SystemReady. And to help us with that, I want to introduce Olivier Bernard, Director of High Performance IoT with Arm's AIoT Group. When he's not helping us understand what is Arm SystemReady, Olivier enjoys watching or playing ice hockey or teaching Taekwondo with his kids at his dojo. So let's get started. Olivier, what exactly is Arm SystemReady?
So Arm SystemReady is a set of standards and certification program that describes and defines interface between hardware and software. Right? Think of it as an abstraction layers that ensures that generic off-the-shelf operating system just land on just about any hardware. At the end of the day, SystemReady allows to disassociate the hardware from the firmware and ensures that software just works.
So, Olivier, why is this important for developers?
That's a great question. So today, the embedded Linux ecosystem is a very healthy and pervasive. It's used in just about every industry because it's flexible, it's got loads of functionality. However, the software stack on most embedded devices is entirely custom. You have to build it to the ground. And the OS is tied to the platform. Even the smallest changes means rebuilding the entire image and downloading it on the device. And that's complicated. That makes maintenance and adding features, especially security features that are always evolving, very difficult, very complicated, and really doesn't add a lot of value to the end user. So that's not the best energy and money spent by software developers. With SystemReady standards, it becomes a lot easier and a lot cheaper to maintain multiple images on multiple products and applications. And this in the long run, so today and tomorrow. So you're building a future-proof system. What it also does, as I mentioned earlier, is it disassociates the hardware and the software. So that means that people and users, OEMs, integrator, can choose the best hardware platform for the application, whether it's smart cities or smart building. And then they can use the best software. And the hardware platform developers can roll out in the field their products, not having to worry about how is my product going to be used, what software is going to be tied to it. It's all independent. So it allows you to deploy your assets in the field and land just about any operating system or application or container on it. And then lastly, for OEMs, it allows you to have software portability and reusability across different platforms. The world of cloud native and the cloud system has been very successful because it's got business principle, IT business-oriented modern software technology deployment. We need to bring the same thing to the OT world, which is what IoT is mostly in today.
That's a great overview, Olivier. Can you describe some of the elements of Arm SystemReady that can speed development time and how that happens?
There's really three components. There is a base system architecture, which is BSA, which describes how the SoC, the device, is being built. Then there is the BBR specification that describes how the system software, the firmware, is being integrated with the hardware to offer a complete solution so that developer can put the application. And then we have this ACS suite, the architecture's compliance suite, that tests the whole system and make sure it's compliant and meets the specification. And that's how you get your certification. But also as part of the certification, we also require to see landing report from unmodified image, ISOs, from commercially available operating system. And that proves that it'll just work. Now, removing the customization, the fine-tuning, the maintenance, the verification, and managing multiple binaries for multiple platforms is a huge cost saving for the end and OEMs. You can literally, for example, with Yocto, have one binary image, and you update your binary image for all of your devices over time, and you just download the differentials.
So already we're seeing some excellent momentum with SystemReady because of a lot of the outcomes that you've just told us about. Can you give us a little bit of how you think Arm SystemReady might evolve in the coming years?
Arm SystemReady was originally designed for data centers, and we saw fantastic successes there to allow the migration of workloads from cloud native to Arm-based servers. And that's what we did. We saw that success and we decided, why can't we take that success to the edge? And that's how we created Project Cassie, extending that SystemReady successes from the cloud to the edge. Now, what you will see in the next 12 months is an evolution of the spec. We've put as much as we could today in the current spec that we released, but there's much more we can do. So over the next 12 months, you will see different rollouts of specification. In addition, today, System Ready only applies to Cortex-A, Lingual from ARM, which are application processors and embedded Linux. But we see that for the complete edge, including constrained embedded devices and MCUs. So to that extent, what we did is we introduced at Dev Summit Project Centauri, which is an extension of Project Cassini, but for the far edge and for MCUs and RTOSes.
Well, Olivier, this is clearly a huge step forward in accelerating system development. So thanks for telling us about it. We really appreciate it. Now, check out all our other What Is episodes here, and be sure to subscribe to this channel because we'll be adding more as the year progresses. Thanks for listening.